Hello, everybody. Today we're going to be building a weather app using Swift Package Manager, Alamofire, and a weather API. So the steps we're going to do are first to sign up for the weather API. We're going to add the Alamofire dependency using Swift Package Manager. We're going to be building the models using structs and Codable. We're going to be building the UI using SwiftUI, fetching the data with Decodable, and hook up the UI with the data. This is only the first of 3 tutorials. In future tutorials, we're going to be using location to select the default weather. We're also going to search weather by postal code, show hourly forecast, weather details view, refresh data, and there might be other surprises. So the first step we're going to take is to sign up for the weather API. So the first thing you'd want to do is to go to the weatherapi.com website and sign up for their free tier. The free tier allows you to get forecasts for 3 days for free. If you were to build a more professional application, then obviously you might want to pay and get 10 days of forecasts or a much longer forecast. So once you've signed up, you get an API key. You can see the API key here. And what I'd like to do is to copy the API key by pressing this button and then going to the API Explorer. So in this Explorer, I can test out various API calls, see what the JSON looks like. And it's really important to look at the JSON before you start building an application because it's going to dictate how you're going to construct it, especially your models. So the first thing I'll do is I'm going to paste my API key here. Then I'm going to scroll down here and I'm going to add a postal code for Scarborough. As you can see, you can use zip codes from the US, UK postcodes, Canadian postal codes, IP addresses, latitude and longitude, and city names. The postal code I'll be adding in is for Scarborough, Ontario, and I'm just going to remove the space here. Now, what I'm interested in seeing is the forecast. So I'm going to click on forecast. And I'm going to select 3 days. So I wanted a 3-day forecast, which is the number of days that I can get with the free tier. And I'm going to click on show response. Here you'll see the API call being made. And this is an important string to copy because we'll be using this within the application. So I'm going to copy that. And then I'll be pasting it into this text editor. Now let's take a look at the JSON. Looking at the response body, there are 3 parts: location, current, and forecast. Looking at location, it provides the name of where the weather's coming from. So that would be Scarborough. Under current, it gives you all the current weather patterns and information for Scarborough at this current time. And under forecast, we have an array of 3 forecast days. And these days include the date and epoch time and the average temperature in Celsius, and also some text here under condition, which says that it's patchy, moderate snow currently. So I'm going to copy this JSON, and I'm also going to save it into my text editor. The next step involves creating a project and adding the Alamofire dependency to it. So I'm going to create a new project. I'll select the Swift app. I'm going to call this project Forecast. I'm going to make sure it's a SwiftUI project. I'm going to click Next and then Create. To add the Alamofire dependency, we're going to click File, Add Package Dependencies. And here you'll see Alamofire. To add Alamofire here, I went to the GitHub repo. I copied the URL, and then I pasted it up here. Before loading in the library, I want to select a particular version of Alamofire. So I'm going to select exact version, and I'm going to pick 5.8.0. The reason I'm not using the latest version 5.9.0 is because I've noticed there's a few errors that come up if I try to use the very latest. So I'm just going back one version. So I'm going to click Add Package. And you can see it's fetching the library, and then it adds the package to my project. The next step we're going to do is to add a line in the info.plist to allow network calls to be made. So I'm going to click on Project. I'm going to select Info. I'm going to add a new line here, so add row. I'm going to type in app transport security settings. Then I'm going to expand app transport security settings. I'm going to click on a little plus sign. I'm going to select allow arbitrary loads. And instead of no, I'm going to write yes. Allow arbitrary loads is a default that allows pretty much any internet connection to your app. For development, it's perfectly fine to do this. If you want to create a production app, it's actually better to specify which domains are whitelisted for your application that you would want to allow to connect to your app. If your app is designed to connect to all kinds of domains, then this would be the best option. If you didn't add this line in the info.p list, iOS would disallow the network connection. Next, we're going to build our model. It's really important to consider the structure of the JSON when building the models, so we're going to put them side by side. The structure is pretty complicated, so I'm going to go step by step to show you how to convert the structure of your JSON to your structs. So the first thing I'd like to do is to create a struct that represents the overall response that I'm receiving from the API. So I'm going to call this struct weather. I'm going to make it codable. So looking at the API response, I want to get the name from the location. And I'd also like to get the forecast for the 3 days. So this is an array of 3 forecast days. I'm going to create a new struct called location. We're also going to make this codable. And the specific variable that I want to get out of location is name. So I'll say variable name equals string. So we're expecting a string for the name. And here in my response struct, I could say variable location is location. So once the API response has been returned, I can now grab the name of the city. The next part of the API response that I want to get is the forecast. So I'm going to scroll down to forecast, and you can see within this dictionary of forecast, there is a variable that has an array of forecast days. So I have to represent that as a struct. So I'm going to create a new struct for forecast. And I'm going to create a new struct for forecast day. So what I'd like to do is show all 3 days using a list. To be able to accomplish this, the list requires that one of the elements is an ID that's identifiable for each element of the list. So for forecast day, I have to not only make it codable, but also identifiable. The reason I'm getting an error right now is because when I add identifiable, the struct now requires an ID. So I'm going to fix this in a few moments, but the first thing I'll do is fix my forecast. So as you can see in the JSON, forecast includes an array of forecast day. So what I'm going to do is type in var forecast day is an array of forecast day. So the first variable that's of interest within forecast day is date epoch, and this will provide the unique date for each day that we're tracking the weather. So under forecast day, I'm going to type var date epoch int. Now, the one thing you'll notice is I'm writing it out exactly the way it's listed out in the JSON. And this is super important. Otherwise, the structs won't be able to decode the JSON response. Now, to satisfy the requirement for an ID, I'm going to type in var ID is of type int. And I'm going to load in the date epoch. So since each day has a unique epoch, I don't have to worry that there'll be 2 conflicting IDs, since they are on totally separate days. So you might be wondering, what is epoch? So by definition, epoch is also referred to as Unix time, and it's the number of non-leap seconds that have elapsed since January 1st, 1970. The iOS platform can easily decode this epoch date. Now, there's a few other pieces of information I'd like to extract from the JSON. The first one is this average temperature Celsius under day. So I'm going to create a new struct called day. I'm going to make it codable. And so I'm going to type out average temp C in Celsius, making sure that I type it out perfectly. and it looks like it's a double. So I'm going to type in double. So the last thing I'd like to pull out from this JSON is the text that says moderate snow. I want to display it in the UI and also use it to determine what emoji to show and what background to show. So I'm going to create a struct called condition. And within this struct, I want to extract the text. In this case, the text says moderate snow. So I'm going to type in var text string. Now within the day dictionary, I want to grab the condition variable that also contains a dictionary. So the way to represent this in a struct would be by typing var condition. The last thing I need to do is to update my weather or the response object. So I can also not only get name of the city, but also get all this new information that I've added. So I'll type in var forecast is of type forecast. The API response will pull from weather. So weather will decode the API response. Within location, it's going to grab the name of the city. Within forecast, it's going to grab the array of forecast days. There are 3 of them. So it'll be 0, 1, 2. Within the forecast day, it's going to grab the date and epoch time. It's also going to generate an ID. And we also want to grab the day. So I'm going to type in var day. So within the day, in the forecast day, it's going to grab the average temperature in Celsius. And within the day, within the condition, it's going to grab the text, which is our moderate snow. So as you can see, everything is hierarchically organized. And it's important to understand how each element relates to each other so that you can correctly represent it as a struct. In this case, forecast contains an array of forecast days that contains a date epoch, that contains a day, which contains an average temperature, which contains a condition that contains a text string. And I know that sounds complicated, but you can see it here in the JSON. The location contains a name. The forecast contains an array of forecast days. Each forecast day contains an epoch date. Each forecast day also contains a day that contains an average temperature and also a condition. And each condition contains a text. So this is the logic and reasoning you're going to require in order to create your model. The next step we're going to undertake is to build the user interface using SwiftUI. So we're going to start with our vertical stack. So I'm just going to delete the default here, and I'm going to turn on the previewer. I'm going to start with a spacer. Then I'm going to add text with the city name. So I'm going to add a city name by default, Toronto. I'm going to make the font of system size 35. Now I'm also going to make it bold. The next thing I'll do is I'm going to add today's date. So to add today's date, all you need to do is type date, which is super easy. But you can see the date is very long. And the part of the date that I'd like to have is Wednesday, March 20th, 2024. So to shorten the date, I could type formatted. And within the formatted, I can say date is complete and time is omitted. So you can see that it'll now present Wednesday, March 20th, 2024. So I'm going to format this too. I'm going to select a font size for this one to be 18. Okay. The next thing I'd want to do is present an emoji representing the weather in a city. I'll type in text. In order to add an emoji, you need to press Control Command space. So in this case, I'm just going to add by default a sun. And the font system size for this sun, I'm going to make it 180. And just to make it pop a little bit, I'm going to add a shadow, and the radius will be 75. Next, I'm going to add the current temperature. So the current temperature would be 0 degrees Celsius. So I'm going to copy the degree symbol. You can just go on the internet and type in degree symbol, and you can find a copy of it on there. And I'm going to paste it right in between 0 and Celsius. Now this one, I'm going to make it of size 70. And I'm likewise going to make it bold. So you can see our UI starting to come together now. So the next element I'm going to add is the condition. So this is the text that we're pulling out of the JSON. So I'm just going to add a placeholder, moderately cold. I'm going to make it size 22, and I'm going to make it bold. Then I'm going to add a couple of spacers. Then I'm going to add a list placeholder. And within the list, I'm just going to add placeholders for the text. Then I'm going to add a spacer. And lastly, I'm going to add attribution for the weather API. So I'm going to type in text data supplied by weather API. I'm going to make this one font size 14, and that's it. This sets up the framework for our UI, but we're going to work with this to make it even better. So I'd like to change the emoji based on the weather coming in from the API. I'm going to create a special function that takes in the text from the condition in the JSON response and then outputs an emoji. So I'm going to add the helper function after the body. I'm going to say function get weather emoji, and we're going to take in the text and we're going to output a string. I'm going to say return string. So if you looked at the string that was in the JSON, it was things like it's raining or heavy snow and all kinds of other things like that, moderately cold. So what we'd like to do is capture all the scenarios and output the correct emoji based on the scenario. So the first thing I'll do is create a default emoji. And by default, it's just going to output the sun. Then what I can do is just say return weather emoji. So I'm going to check the text in the condition part of the JSON, make it lowercase so I can look at every single condition like rain and snow and make sure I display the right emoji. So I'm going to type in let condition text equals text dot lowercase. Now I'm going to use a series of if-else statements to check the condition text to look for specific words and to output an emoji. For example, if condition text contains, and if the word snow, then my weather emoji should be that of snow. So I'm going to select the weather emoji for snow. So another word that's used within the JSON is also blizzard. So I'm going to say if the condition text contains snow or contains blizzard, then show the snow emoji. So now we're going to handle rain. I'll type in else, and I'm just going to copy this part. If condition text contains rain, then the weather emoji should be rain. So I'm going to select the emoji for rain. Now we're going to look for partially cloudy. So I'm just going to copy this. So if the condition text contains partly cloudy, then we're going to add the partly cloudy emoji. And you can see how this is working. Now we're going to look for cloudy and overcast. So I'm going to select this part here. So it's useful to copy paste sometimes to make this a little easier. So I'm going to type in cloudy and overcast. Then I'm going to put a big storm cloud. And lastly, we want to look at clear and sunny. So I'm going to copy this code here, change it to clear and sunny, and change the weather emoji to a sun. So once again, the way this function works is it receives the text from the API stating what kind of weather it is, and then it outputs an emoji based on that text, looking for keywords. Another thing I'd like to do is to change the background color of my app based on the weather. So I'm going to create another helper function to change the background color based on the text under the condition node. It's going to accept the text, which is the text from the API, and return a color. To get rid of this error, I'm just going to type in return color black. The next thing I'd like to do is to define some default colors for the blue sky and also the default gray overcast sky. So I'm going to scroll up here, and under content view, I'm going to say let blue sky equals color.init. And then it's going to accept a value for RGB, red, green, and blue. So I want to put in a blue color. So I'll type in 135 over 255, 206 over 255, and lastly, 235 over 255. Now, if you don't add the /255, these colors won't initialize, just to let you know. Next thing I'll do is add the overcast sky. So it's a gray color. So I'll say gray sky equals color init. So very much the same process. And for red, we're going to add 47 over 255. Green's going to be 79 over 255, and blue is going to also likewise be 79 over 255. Now, I'd like to create a state variable that tracks the current color so that we can use that state variable to change the background color at any time. So I'll write state var background color equals color.init. And I'm just going to repeat the color for the blue sky. So I'm just going to copy and paste this here. Now we can complete our helper function. So I'll scroll back down. I'll say var background color equals blue sky. So that's going to be our default color. and I'll say let condition text equals text dot lowercase, much like the previous example. So I'll say if condition text dot contains clear or condition text contains sunny. So this exclamation mark means not. So if it's not clear or not sunny, then the background color should be gray sky. So I'm basically saying if the background color, by default, the background color should be blue. But if it's not clear or sunny, then the background color should be gray. And what I'll do here is change this to background color. So now our second helper function is complete. We're going to create one last helper function. And this helper function is going to provide us with the date. So it's going to convert epoch time into a normal string. The string is going to say the weekday in an abbreviated form, so only 3 letters. So for Wednesday, it'll say WED. So my function is going to be called get short date. I'm going to accept an epoch integer from the API. And I'm going to return a string. So I'm going to type in return string just so that to make the error go away. And what I'd like to do is return a date. And within this date, I want to do a time interval since 1970 to be a time interval of epoch. Now, I want it formatted specially. So I'll say formatted, and I'll say date dot format style dot weekday. And then within here, I'll say abbreviated. So once again, the way this function works is that it takes in an epoch date, which is a long integer. And based on that date, it'll return either Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday as a short 3-letter date. Now we're almost done. We just need to create state variables to populate the UI and make the API call to fetch the data. So I'm going to scroll up here and I'm going to add some state variables. So the first state variable I'm going to add is for the emoji, and this will allow me to switch up the emoji. So I'll say var weather emoji equals, and I'm just going to put in a default emoji for now, so it'll be sun. Next, I'm going to create a state variable for the current temperature. So I'll just say current temp equals 0, so it'll be 0 degrees by default. I'll create a state variable for the condition text. Then I'll create a state variable for the city name. I'm adding Toronto as a default. Now I'll create a state variable to check whether the API is loading or not. The next step is to create a helper function to fetch the weather from the weather API. So I'm going to scroll down here. I'm going to create a new function called fetch weather. I'm going to make it async because I don't want this API request to occur on the main thread. Before I start anything, I need to import the Alamofire dependencies. So I'm going to scroll up and say import Alamofire. Then I'm going to scroll down back to my helper function. I'm going to say let request equals af.request. And within these double quotes, I'm going to paste that link that I copied earlier from the Weather API website. This was the curl request that I made to get the forecast. Now I'd like to decode the response from the API using my weather struct. So I'm going to type in request.response decodable. So now we're going to look to see whether the response is a success or a failure. So I'm going to use a switch statement to look at the response result. I'm going to dump the weather object, which is the entire response from the server. The next case is a failure. And in the case of error, I'm going to print off the error, but obviously you may want to handle it differently and show some sort of prompt to the user to tell him that the request couldn't be made successfully. It could be the user's offline and there's no internet connection. It could be a variety of different reasons why an error may come up. So I'm going to comment out the dump, and we're going to start loading our state variables. So the first state variable will be city name. We're going to type in weather, which is the entire response, dot location, dot name. So city name will be returned from the API, and it should be Scarborough. Now we need to create a state variable to contain the array of forecasts. So I'm going to scroll up to the top and write, the results will contain every single forecast that's received. Now I want to pull out the array of forecasts and put them into results. Next, we're going to grab the current temperature from the response. We're then going to set the background color. Then we're going to set the weather emoji. Then we're going to get the condition text. And lastly, we're going to set loading to false. I'm going to uncomment dump weather. Now, once the VStack UI is loaded, then we're going to use a task to fetch the weather. I'm now going to run the app on my phone and check the API response to make sure the app is functioning correctly. As you can see, the dump decoded the data correctly. The last step is to add pizzazz to our application. So we're going to add colors and live data into the UI. I'm going to start by adding the background color to the UI. Then I'm going to modify the frame. So this frame will make sure all the content is top leading. The next thing I'll do is add the correct city name. And I'm also going to change the foreground color to white. For the date, I'm going to change the foreground style to white also. For the emoji, instead of the default, I want to replace it with the weather emoji. You can now see it's dynamically switching to the correct emoji. Then here under 0 degrees Celsius, rather than having a default as 0 degrees, I want to put the current temperature. So I'm going to put current temp, and I'm also going to make the foreground style white. So for the current weather condition, instead of having this default moderately cold, I want to put the actual weather condition coming in from the API, which is patchy moderate snow. And I'm going to change the foreground style to white. So now our UI is starting to look good. There's a few more changes, and then it'll be perfect. For the list, I want to remove the space at the top. So I'm going to set the content margins for vertical to 0. Now, obviously, the gray color really clashes with our current UI. So I want to remove that. So I'm going to put in scroll content background. I'm going to put hidden. So you can see it takes away the gray. Now, at the very top, it's not visible here, but on a phone, you can see the time at the very top and whether you're connected to a Wi-Fi network or your cellular network. By default, that's black. So what I'd like to do is to change that to white. So to make that text white, what you need to do is type in preferred color scheme to dark. And so the text above will be here will be white. So we're going to take a look at our attribution. Just like I did for the other examples, I'm going to put the foreground style to white and just declare it explicitly. Now, you remember that we added a list of forecasts in the results. So what we're going to do is iterate through those results to populate the list view. So I'm going to put in list results forecast in, and now we're going to build our UI. So the first element I want to build is to get that short date. So it'll say Wednesday, Thursday, or Friday at the beginning. Then I want a weather emoji to show up in each row. Then I want the temperature. And at the very end, I want the text, which is the condition text of what the actual weather is like. So I'm going to create an H stack. The alignment will be center and the spacing will be nil. So within this H stack, I'm going to add the text for the short date. I'm going to type in get short date epoch, and the epoch is the forecast dot date epoch. And as you can see, it put the correct date. The frame, the max width will be 50, and the alignment will be leading. So what I'd like to do is make sure that all the various elements in each cell are aligned correctly. The next thing I'm going to do is make it bold. Then I'm going to add the mini emoji. So we're going to get the get weather emoji. I'm going to type in forecast.day.condition.text. So you can see a little emoji pop up. I want to set an explicit frame for this too. So I'm just going to copy this line of code. And instead of 50, I'm going to make it 30. And you can see that we now have the date and then we have an emoji beside it. So we're well on our way here. The next thing we're going to do is add the average temperature. So I'm going to type in text forecast.day.average temperature. So what I'd like to do is add the little symbol and see. So I'm just going to copy it from here and put it here. And lastly, I'd like to add the condition text to outline what the condition is. So I'm going to put a spacer. Then in the text, it's going to be forecast.day.condition.text. And I'll set a frame for that one too. Now, the one thing I forgot to do was to add a frame to the temperature. So I'm just going to add a frame of 50. You'll see the UI change slightly. All right. So the black doesn't look that great. I'd like to make it kind of blurry and nice and white. So I'm going to use list row background. I'm going to select color.white.blur. I'm going to set the radius to 75 and the opacity to 0.5. And there you go. You have the entire user interface. Congratulations, you just built a weather app. It pulls from the weather API, populates structs with Codable, decodes into a weather object that you can use, and then populates the UI and presents the information to the user in a very attractive way. Thanks for listening.